to
Hello.
the show, Jeremy.
Thank you. Thanks for having me. It's good to
I'm
see you
really,
again.
it's always a pleasure to see you. I'm really excited about this today because we're going to be talking about the history of AWS Lambda um, with Jeremy. Jeremy, like before we dive in, I'd love to get the audience to get a little bit of an intro about you, your background, and you know, and then before you get into what your background with Lambda is, let's just share a little bit about who Jeremy is.
Sure. So I've been doing this for longer than I'd care to admit, but basically I started at my career. Actually, I started my career at SendMail, and then in eBay and PayPal, and I did security and anti-fraud work at eBay and PayPal. Then from there, I went on and to Reddit, where I was the first employee at Reddit. So I did most of Reddit's infrastructure. I moved Reddit from a data center in Boston to San Francisco, and then from San Francisco to AWS. And we were one of the first big websites in AWS. And then, that's how I got selected to be an AWS hero from that work. Then from Reddit, I moved on and was the first SRE at Netflix. So I joined Netflix right when Netflix was starting the whole streaming thing. They were the company at the time that I joined them. And then we built up a whole SRE organization around reliability and, alerting, monitoring. Obviously, Netflix was huge, all in on AWS. And that was where I Lambda. But ever since then, I've started a couple of companies around cloud infrastructure. And yeah, both of them actually were about cloud infrastructure. And then I left and I actually worked at Alexa for a while, helping Alexa use AWS better. And then most recently, then I went and took the head of product at Lambda Labs, which makes a GPU cloud. And then I recently took the CEO job at DBOS, and we basically make a serverless compute platform, which is cheaper, better, faster than AWS Lambda, and has workflows and step functions and all that stuff built right into it. And so
Wow.
that's been my journey over the last 25 plus years.
Well, being employee one at Reddit and running so much of Netflix infrastructure as the SRE, that's big shoes to fill. So, um, I'm guessing you were at Netflix when you heard about Lambda.
Yeah. So the way I heard about Lambda was AWS came to us. Actually, it was almost exactly 10 years ago today that they came to us and said, "Hey, we're launching this whole new thing at reInvent, a whole new compute platform, and we want to read you guys in on it and get your take on it, and we're going to give you early access to it and let you use it." And we were like, "Sure, that sounds really cool." And so they gave me access, me and a couple other guys, I think, on the SRE team, and I was the first one to use it. And we just tried it out. There was no libraries for it. There was no APIs for it. You literally had to take your Python code and shove it in a zip file and upload it to S3, and then go to the console and say, "Here, my zip file is over here in S3. Please run that for me." And that was pretty much the Lambda interface at that time. And then, and I found out later from the product manager that I was literally the first person outside of Amazon to ever use AWS Lambda, uh,
Hmm.
because we were the first ones to get early access to it. And so we did that, and they liked what we had tried out with it. And then they asked if our chief product officer would do the keynote at reInvent to announce Lambda. So the Werner was going to announce it, and then our CPO was going to come on and talk about what Netflix is doing. So I ended up
Hmm.
writing that keynote for him to present during reInvent. So I basically wrote the AWS Lambda presentation for reInvent, not the Werner part, the customer experience part.
Sure.
And so yeah, that was how I ended up being the first person to use it and having that experience.
Yeah, I actually remember it was in um, Works for a while. It initially started as this notion around simple compute service because it started off in the inside of the S3 team. And
Mm-hmm.
initially, I think the team just wanted to give people like Don McCaskill at SmugMug ability to, generate thumbnails in in real time as you download data off of S3. And as the team started to kind of go around that, they were like, wait a minute, you can do a lot more than just, re-render images on static objects. Like we can make a whole compute platform out of it. So tell me about what the unpacking experience was like uh, when you got access to Lambda. And so sure there were fewer libraries and so forth. What did you deploy, and what was the hello world like for you?
Yeah, so there was no hello world. I mean, literally, I deployed a hello world, a Python hello world, deployed it to Lambda and hit an API endpoint, and it said hello, Jeremy. And I had to create that myself, but it worked, right? And then the next thing I did was the one thing they had available were S3 triggers, because
Yep.
for the reason you just said, because they were originally building it with an S3. Built a little demo app out of, okay, we upload a file to S3 and it does a thing. And at the time, of course, Netflix had this entire infrastructure for the way people would, movie companies would send us digital files called mezzanines of their films, right? And these are super high resolution. And then we would render those out to all the different resolutions necessary for streaming. And, we had a whole infrastructure for doing that, but I sort of set up like a demo pipeline of the same thing using Lambda. So they put the file in S3, we take it and we put it into our infrastructure for rendering, stuff like that. So that was actually the very first sort of real thing that I did with it. And then it was all basically prototypes. So we did a little
Hmm.
prototyping on using Lambda to check security, right? And I don't believe they had any way to run a Lambda on a schedule yet. So we had a cron job running in our own infrastructure that would hit an API that would trigger a Lambda to run, that would do some AWS stuff like troops
Hmm.
and things like that, and then send us an email with you know stuff like that. So built that kind of a prototype. What else did I build? You know what? I actually went back here. Let me go look at my notes. I went back and I looked to see what else we talked about. Oh yes, dashboards and monitors. So we did build
Nice.
some stuff. I built some prototypes on using lambdas to update dashboards, update monitoring stuff. Where it was the a thing would happen. It would call an API that existed in Lambda, and then it would do a thing and put it somewhere else. Because that's pretty much all at the time is call your lambdas. There weren't a lot of trigger. Like I said, I think it was just S3. There was probably, yeah, I think it might have just been S3.
It was S3. I know you guys weren't using, or the Netflix team wasn't big on Dynamo at the time, so Dynamo Streams worked with it as
Right,
well
right,
at the time.
right. And
And
we weren't using any Dynamo because we had our whole own structure.
that's right. There was the Cassandra
Yeah.
side of town. But so you said you did your initial Hello Worlds in Python. Was that the only language available, or were the other options then? Because now you can write
I
lambdas in so many languages.
yeah. I think it was. I think they had Python at the time.
Okay,
And
yeah, that sounds about right.
yeah, and I hadn't written Java at that point in since college. So
Hmm.
it had been, over a decade and a half since I'd written any Java. But I was actively writing Python every day. So I chose Python because of that. Turned out to be the right choice though, because of the cold start problem with Java. Most of what I'd written probably wouldn't have even worked in Java anyway.
Yep. Yeah,
Interestingly,
like
Netflix itself was almost all entirely written in Java at the time, except for the
yep,
stuff that my team was doing. But
that's right. I mean, the SRE folks could get away also with a lot more Python. I think that at Netflix, Java was more the infrastructure stack. I think was more Python, right? If I remember properly.
Yeah, so basically everyone on SRE preferred Python. So we wrote all of our tools with Python, and we wrote some of the Python libraries that interacted with the other Netflix services because they only existed in Java. And so we essentially ported some of the Java libraries for the ones that we needed. But yeah, like 95% of Netflix was written in Java.
Yeah, Rust wasn't even a thing really yet. So now all the cool kids like Ben Pyle are writing lambdas in Rust and benchmarking them. We just got a comment from one of the other OGs, Andrew Shee from SmugMug, who believes YouTube has been spying on him because this talk got recommended early. I bet he was also one of the earliest folks using it for the photo processing because
Yes.
he was at SmugMug and was probably toying
Yes.
around with the simple compute service aspects of it as well. Um, so was there API gateway at the time? Well, how would you
No.
invoke the lambdas? Was it just via the
No.
triggers and API calls to the lambda itself?
You would call directly into the Lambda itself. Yeah.
Yeah, and there was
And
no
I
lambda
and it,
function URLs, right? You would just literally
no
call lambda.
calling. Yeah. You'd have to call directly you'd have to call the function directly. Yeah. There was no HTTP endpoint or anything like that.
Yeah, that I think when how do I say this? I feel like in like a old old timer when I say like when people log on and deploy their functions to Lambda and just can magically see it in the browser. That's not how it was back in my days.
Yeah. Yeah. It was definitely much kludgier then. It worked, but I mean,
Mhm.
that makes a ton of sense, right? Like it was the beginning of a service. It was the very much the let's get this out there. Let's get product feedback. Let's get customer feedback and iterate from there.
But I think those limitations also inspired more of that event-driven architecture. You don't have to invoke every single microservice via an HTTP URL.
Yeah.
And hooking Lambda up to trigger. For me personally, that was magical. I had a talk that year at reInvent where we talked about how it was, you can write basically Snapchat with 50 lines of Python code. I mean, it's not all Snapchat, and we couldn't say Snapchat,
Mm-hmm.
but it was literally a photo sharing service where you would index the item in Dynamo, and you can count the number of likes it gets and so forth and whatnot. So you did some toy applications, like you said, like the Hello World applications. You wrote the keynote
Yeah.
for Netflix component in Werner's keynote. What was the first production app that you deployed in Lambda? And like, what did it do, and why did you pick Lambda for it?
So it's funny. He didn't really end up using it for production use cases much at Netflix until after I left. So
Okay.
and I left. Well, let's see. Lambda came out in 2014, so I left shortly after. Right. So I left Netflix in 2015, and they used Lambda from what I heard after that. But yeah, we didn't get a lot of production workloads right away, mainly because of all the kludgy problems with it, and we are going to do all of that. My first production workload was actually at the startup that I did afterwards. We built the entire startup on Lambda.
Mm-hmm.
Amusingly, one of my co-founders was the guy who wrote Bodo, Mitch Garnett, and he, of course, had written all of the Bodo libraries for Lambda as well. And so he wrote a Lambda deployment framework company that we open sourced because at the time there was a bunch of them, right? So everybody was making a Lambda deployment framework. Ours was called Kappa. We're very clever about Greek letters, and it was a pretty good one as far as all the rest go, but we didn't really maintain it, and it kind of died on the diet. But yeah, he wrote that, and we used that, and our entire startup, which was managing cloud infrastructure, was deployed on Lambda. So we had,
Wow.
10 different microservices. They were all interacting with each other. They actually worked pretty well. Uh, Lambdas for other stuff. So we were also doing consulting work at the time to bring in revenue. And we would use Lambdas in our consulting. We would companies to do small workloads, event-driven workloads. But yeah,
Mm-hmm.
the first production workload that I managed on Lambda was our startup, where we were managing cloud infrastructures. We were providing a essentially a chat bot that allowed you to query your cloud infrastructure. And so all of those would go into the Lambdas, and it would take in your request, it would process your request, it would do some querying and send an answer back to you on Slack. So it was a whole Slack bot and the whole thing.
All you had to do was launch that startup today and call it a Gen AI bot, and you'd be raking in money.
It's funny you mentioned that, because actually one of the demo apps we built at DBOS is in fact a Slack RAG application
Say more
doing
about that.
exactly that.
What did you build?
it's a Slack bot that sits in your Slack channels and it listens to everything that you say. You stores all of the conversations into a vector database, and then you can ask it at any time for any query you want, and it'll use the content for everything that has ever been said in the channel since it started listening.
That's awesome.
Right now, of course, we're just using it for fun stuff. So and so has a pet, and then the next day you ask it, "Does so and so have a pet?" And it'll say, "Yes, they have a cat."
That's cool.
But it's
Lambda
actually super helpful.
Mm-hmm. No, I bet. Like, I think you can keep in. We'll get into DBOS shortly as well, because
We'll talk about
I
that
want to
later.
kind of do a continuation of, it's the early days of Lambda. No HTTP, no API gateway, no function URLs, no cron jobs, just Java and Python support. And
Yeah.
I'm curious, like, what's been your favorite addition to Lambda so far?
Ooh, my favorite addition, the HTTP endpoints are probably a really big one. That made life so much easier, right? Being able to deploy. Another one that was huge was the console. When they upgraded the console so that you could edit your code directly in the console, that was huge too, because a lot of what Lambda gets used for is prototyping, and it's way easier to do that when you have that code right there. I'd say those are probably the two favorite features.
And when you say HTTP, do you mean via the HTTP API gateway or via the Lambda function URLs?
The direct, Lambda function URLs, right?
Yeah, bypass API gateway.
Yeah, gateway
completely.
was interesting, but a little complicated. Having that directly was fantastic for rapid development, because you deploy a function, you get a URL, doing the thing you want to do.
I think for folks coming on to Lambda after the advent of API gateway, it's many of us see API gateway and Lambda as somewhat atomic. And it's really important to see Lambda as its own individual service, because there are cases where it makes sense and it's better to just use it on its own without necessarily using API gateway. And I'm a big fan of API gateway, especially after the team, because initially API gateway only had REST APIs, which, it's like $3.50 per million requests. It's really expensive. But then they added the HTTP APIs, which are a third of the price. So, quick call to action: if you're using API gateway with REST APIs and you can really get away with the HTTP API functionality, you can drop your cost by 66% on API gateway. But it's much nicer to just to go from $3.50 to $1 per million requests to even like 20 cents per million invocations with API with Lambda function URLs. So in many cases, if you don't need the auth, especially if the API gateway is just sitting on a public channel with no auth, or your auth is being done inside of Lambda, like just use the function URLs.
Yeah, totally. Yeah. It's the API gateway for a lot of use cases is overblown, and that's why I was excited when they gave when they made those Lambda URLs directly, because you could skip the complexity of the API gateway that was often unnecessary.
That's right. So this year at reInvent it's it's funny. It's ECS and Lambda's 10-year birthday parties. So Lambda is turning 10 at reInvent 2024 in just a couple of months. And if you could whisper to the Lambda product managers or the engineering leaders or general manager one feature that you would love to have in Lambda, what would that be?
You've put me in a difficult position since I build a Lambda competitor. I would tell them, don't ever innovate again, because it's perfect the way it is. So that I can innovate it myself. But no, I mean, I would say probably the biggest issue is still, they've done a lot of work on cold starts, but getting those so any functionality that they can imagine that would bring that down, either freezing or automatic warmth or something that would make sense for the way they build their workloads. I would say is probably number
Yeah.
one.
Yeah, my big ask personally would be around multi-threading. Like a Lambda that can handle more than one request at a time would be super
Mm.
useful. And it kind of goes like it's kind of blasphemy to a certain extent because that's like a Lambda thread is supposed to be like, unique, but
Well, so that's interesting, right? Because that's really a response to cold starts, right? Like,
it's a response to cold starts. That's one part of it, but the other part of it is, in the traditional server architecture, I can there's I can be processing thousands of concurrent requests, but my underlying connection pools, I can get away with like 20 connections. And I can't do that in a
okay.
Lambda. There's literally a one-to-one mapping. So the underlying services, especially
Yeah.
if you're using a non-serverless type of service without an API layer on top of it, like if you're talking to Redis or if you're talking to RDS directly, you create having a database connection for every concurrent user is really egregious, and it puts toll on the underlying dependencies as well.
Yeah. So yeah, multi-threading would solve that, or connection pooling.
Yep. Yeah, like a Lambda
That's a good
layer that
point.
can do connection pooling on your behalf, but can be shared amongst multiple Lambdas.
Yeah.
um, that would be
But
my
that kind of
wish.
breaks their whole model, right?
A little bit. I think I didn't say it was going to be easy, so um So the other things that have come out since the Lambda launch is also things like step functions and workflow management and going really deeper into triggers. So what happens is, you know, people can stitch together a lot of workflows, but you're usually wielding databases, your compute, your API gateway, your authentication. It can get out of hand pretty quickly. So
hmm
I'm curious, tell me a little bit more about what DBOS does and what your view is of on the number of moving components and being able to serve a simple HTTP call.
Yeah. So you really the main selling point of our company. Thank you so much for that. Is that we we combine a lot of those things together. If you'll see, you'll like 8 different you know AWS services that we collapse into two, our service and database. And so that's exactly right. So we have workflows built right in. We have steps built right in. We have storage built right in. We have state built right in. And these are the main problems with serverless compute today. Is all of those are separate things that you have to manage separately, and they all have to talk to each other separately. And so, for us, a change in state, going from 1 millisecond call to the database instead of 100 millisecond external step monitor, right? Stuff
Hmm.
like that. So that's how we get a ton of performance gains. We're 25 times faster than Lambda. So we can do that because everything is there. We're sort of breaking that whole everything is a separate service model and bringing that's kind of our main innovation is we're bringing workflows are right there. Your storage is right there next to your code. And by doing that, we're essentially bringing everything together. We actually use stored procedures in the database, but you never have to procedure. We generate them for you, we manage them for you, we run them for you. So that's another case where we're sort of bringing code closer to the data, but in a way where you don't have to worry about it. And that's kind of our main selling point is we are vastly simplifying a lot of the problems with serverless compute today.
So let me read that back to you in terms of what I understand about DBOS is
Yeah.
you run on top of a relational database, so Postgres, is that right?
Yeah. So we run on an AWS bare metal instance, and
Hmm.
then we connect a Postgres database, any wire compatible Postgres database. So RDS, Supabase, Neon, any. But yes, everything is in the database. There's two tables. There's like a management table and a data table. You fill the
Hmm.
data table, we fill the management.
So is it bring your own Postgres? Like I bring my Postgres and tell you and give you some permissions to be able to touch my Postgres.
You can bring your own, or we can provide it for you.
Got it. And then what do I interface with you with? So do I give you, like, let's say I want to, like a very simple application. I give in a student's last name. I want you to send back their first name.
Hmm.
How do I make that work in DBOS?
You would write a Python function that says
Okay.
take input and store it, like any Python function that uses a database. So you can use, your favorite Python ORM, uh,
Okay.
and then you would decorate it. So that's
Hmm.
where our power comes from. Is you use our library, which provides you decorators, and you say step 1 is take in the name, step 2 is return the name,
Hmm.
and that's a workflow, right? And so the beauty of that is, because we separate the steps, we don't charge you for the time in between. So you would get charged for however many microseconds it took you to ask the user for their name and however many microseconds it takes to return that back. But there will be no
So
charge for the waiting in between.
you compile the Python code into a Postgres storage procedure. It lives inside the database.
Um, it depends. So the
Okay.
workflows can get compiled into store procedures. Your actual code is just running in a Firecracker VM.
I see.
Yeah,
Got
yeah,
it.
yeah. So your actual code's running in Firecracker VMs. The workflow annotations are what gets compiled into stored procedures.
Okay.
That makes
Understood. So
sense.
the
Yeah.
if I have to do multiple round trips to the database, you can push those down into the database layer.
Yes. Yes, we
Okay.
can.
Got it.
Or you
Got it.
can.
Mhm.
Or you can. It's still regular Python with a regular
Yep.
database. So you can do all the fancy things you want to do, right next to each other. It's much quicker.
Got it. So is this where you see serverless going in terms of, because there's different models, right? Like I come from
Hmm.
the DynamoDB school of thought, which is like keep the database as dumb as possible, and I don't mean that pejoratively. Um, and I've spent my life telling people don't get too excited about how complicated your relational database can get because it could get uh, unpredictable at that point too. So how do you
Hmm.
like do you see this the direction that people are heading and why not?
So I have been 100% on board with you. Keep the database dumb, keep the application smart, and keep it, separation of concerns. But I think that is what is causing a lot of our problems, right? Is, oh, now I have a bunch of communicate and coordinate with each other. I think we got, I think we went too far into separation of concerns. Uh, and the reason we did it is because, like, it was hard to debug stored procedures, right? Nobody likes stored procedures because they're hard to debug, especially in a distributed environment. But what we've done is we've made that so easy because you don't have to even write those procedures. We have our open source framework that just lets you test it locally. And so what
Mhm.
we've essentially done is abstract all of that away. And so, yeah, I really do think that is where, because that is what is going to solve a lot of the emergent problems that we have seen with serverless compute in the last 10 years. And the reason we stifled adoption of serverless compute is because of these problems that we're trying to solve by actually bringing stuff back together in a way that's abstracted from the user in a smart way, in a very academically clean way, basically. So our company has come out of a bunch of research that was done between Stanford and MIT, led by Mike Stonebreaker, the guy who created Postgres. So, his belief was, if we bring everything closer to the database, it will eliminate
Mhm.
a lot of overhead, a lot of extra steps. And so that's a lot of what we're doing. And I really think that serverless compute needs to go to
Mhm.
to solve the sort of inherent problems of concerns and networking between them. And the reason that people don't like microservices, that they don't like lambdas, is because of all that overhead. And so it eliminates a lot of that overhead but still getting a lot of the same advantages. Because really, serverless compute is simple, right? The whole The whole thing is you don't have to worry about your server as you can scale to zero. It's
Hmm.
not so much about separation concerns, microservices. Those were sort of things that happened because of it. And so we're now trying to figure out, oh, well, we can get all of that advantages.
Got it. No, that's pretty cool. And one other thing, I was going back on the rest of our interview and thinking about my favorite launches of Lambda, and I realized that um, you just mentioned you're using Firecracker. Like that came out of the Lambda team.
Mm-hmm.
And
Yeah.
I'm curious what your experience with, well, actually, for the audience, like, do you want to describe what Firecracker is, what it does, and what your experience with it has been?
Is essentially a micro VM, right? It's a tiny virtual machine that fires up within milliseconds. And it is what my understanding is what the Lambda itself is based on. Is that's what they use to run the Lambda service, right? So every time a Lambda has to start, it needs to start a virtual machine. So they created a super lightweight virtual machine, and that's what we use. So they open sourced it. Thank you, Amazon. And that is what we use. We run a fleet of firecrackers, and they're super lightweight and super easy to manage. And that is why we settled on that. But yeah, that part of it is super solid.
How hard was it to like onboard with Firecracker versus like running your own Docker, for instance? I can appreciate the performance differences, but I'm curious if you have any thoughts on Firecracker versus just running in your own Docker world.
I mean, so that you'd have to ask my eng team about. I cannot. We never even tried to do it with Docker or Kubernetes, or like our entire premise was to never use those things.
Hmm.
So we never tried. But
Got
from
it.
what I have seen, it seems to be significantly easier
Got
to
it.
run Firecracker.
Yeah, I've always been intimidated by running Firecracker. I mean, it's such a powerful thing, but I always imagine it would be really hard to get it set up. So this is giving me inspiration to go try the micro VM that's, we believe, behind every Lambda, and Amazon
Yeah.
has been putting a ton of innovation on it to speed things up as well. Um, the other part that gets me with lambdas and the prolifer as I make more and more microservices is atomicity becomes harder to go back to the database world. So tell
Mm-hmm.
me a little bit about how you handle atomicity, and like if I have to do a check and set on a particular item to make it really simple. How does
Yeah.
that work in DBOS versus talking to a regular traditional database?
So we use we use a totally vanilla plain Postgres. We don't
Mhm.
modify it in any way. We do absolutely use transactions to keep everything right. So we figure out, and that is really what the crux of our innovation is what needs to be together in a transaction, what does it, and so we figure all that out for you. We do all that for you, and that's sort of our big innovation is these things need to happen together. Action, what happens if the transaction fails, stuff like that. And so yeah, we have the two different databases, and the beauty of it is you can because we track, well, not every state change, we track every important state change. You
Mhm.
can roll back, you can time travel debug that. that is all that all ties back together with the database is your state manager, and that is give it all, right? Is the database is your state manager. The database already has ACID, it's already got atomicity, it's already got transactions. So we take advantage of that. We make every by taking advantage of the fact that it's a single row entry in the database that is an atomic operation that can be rolled back.
Got it. Got it. Um, One of my favorite launches in the world of Lambda was Snapstart. I really loved it when it came out, and I think to this day it only works with Java. I'm curious if you had any thoughts on Snapstart. You mentioned you weren't deeply into Java, but I'd love to hear your thoughts, and I'm also happy to share mine on Snapstart too.
Yeah, I mean, so I mentioned earlier, right? One of the big things that they should solve is quicker startups, cold starts. Snapstart was a response to that, right?
Hmm.
Snapstart was How do we make Java start? And it's a great innovation, and it was very clever the way they did it, the way they implemented it. Right, I believe the way they did it is function once and then freeze everything, and so the next time it runs, it's sort of already done the initialization stages.
Well, that's exactly right. A lot of people, when they complained about Lambda's cold start, especially with the JVM, what they didn't appreciate was that so much of that cold start was the cold start of a JVM as opposed to the Firecracker starting.
Yeah,
And the
yeah,
JVM binaries are also a lot larger. So when I was inside of Amazon, I would go complain to Mark Brooker about, hey, like my Lambda is taking forever to sign to start up. He's like, well, what language are you using? And I would say Java, and he's like, well, there's your problem. Like you should go like
yeah.
write it in Go or write it in Rust. Like, you're gonna get much faster starts. Um, and I like the approach, like the freezing and then copying the initialized JVM. I thought was brilliant. The one thing that I would wish they would solve, and I don't know if it's actually solvable, is there's a whole lot of initialization that also occurs as with regards to establishing connections with the underlying dependencies and so forth. And
Hmm.
a lot of the cold start is associated with just, I gotta go do my, and especially if you're secure and you're using TLS between your Lambda and your underlying dependencies, well, you gotta do an entire SSL handshake for your Lambda to bootstrap. So it's the
Right.
JVM startup, it's the TLS handshakes that you got to make with each of your dependencies, and that's when your Lambda is warm enough to kind of move on to as well.
Yeah, that's interesting about the TLS, right? Because how do you freeze that and
You
maintain the
can't.
security? You can't.
Yeah, you not without things like perhaps RDS proxy, but or some form of a load balancer, I guess. Like, I mean, I'd have to think harder about how I would go solve that. Like, what you would need is like a lower turnaround time proxy that can kind of multiplex so that not
I
each
mean,
thing is establishing a connection.
yeah, you'd probably want a proxy that establishes the SSL, and then your Lambda would have a hard cut or something that would get from KMS, and you know that where you don't need to negotiate. You have a shared key
Yep,
that you
that's
can
right.
both get access to get to that proxy that then sets up the SSL connection,
That's right.
something like that.
So, yeah. um, I'm curious what your take is on step functions and, or the new trend or newly codified trend around event-driven architectures.
So, I mean, the concept of step functions is fantastic. Obviously, we
Hmm.
think we think that's great. I think it's great. Slow, it's cumbersome, it's hard to use, and the biggest issue is every step. You have to talk to a central coordinator,
Hmm.
and that is slow and risky, right? And I'm sure that the coordinator underneath is well built and reliable and so on and so forth. But from my point of view, it's still a single. So that is, those are the biggest issues with steps. But I mean, the biggest issue is how long it takes to to move from one step to the next, because everyone requires talking to the coordinator, waiting for the response back.
Got it. Got it. So as I recount through the history of Lambda, we started with, its humble origins as the simple compute service, talked about how it launched with just
Hmm.
Python and Java, the advent of API gateway, and then things like step functions and event bridges. Do you think we missed any parts or any other parts that are relevant to the evolution of Lambda so far?
Well, I mean, to Amazon's credit, they've done an amazing 10 years of adding a trigger for everything, right? They clearly at some point decided we're going to make everything that can trigger anything that can generate an event will be able to Lambda. And that
Hmm.
I think was that that made Lambda a viable glue for all the rest of AWS. Is everything can be
Absolutely.
triggered, and now they allow third-party triggers. So it's I think that was probably the smartest innovation that one of their product managers ever had was let's get every single thing we can that generates an event on here. And then let's think of new things that can generate events and get it on here as well, right? I mean, event manager, step functions, these are all things that were essentially created to generate events to trigger lambdas.
Yeah, I guess that's a good way to summarize. I think over time, AWS has really innovated over the last decade with it to make everything be very easily event driven. They've left an opening on
Yeah.
the tighter integration on the database side, which is where DBOS comes in. But I really admire the pace of innovation there and how much more powerful lambdas have also become over time. Um,
Yeah.
Jeremy, it was a pleasure talking to you. Any final thoughts to add or any calls to actions for our audience before we sign off for the day?
I mean, it's been 10 years and since Lambda started, and it's become the glue. It hasn't been adopted as much back 20 I remember in 2014 when we first saw it, everyone was blown. We were like, this is
Hmm.
going to be the new paradigm. Every workload in Amazon is going to change to Lambda because it's just going to be so much easier. Sadly, that didn't pan out. A
Yep.
lot of people still run on EC2. The common wisdom today is, oh, well, when you get enough traffic, you just move to EC2 or bare metal or whatever it is, right? Um, Hopefully we can solve some to do that. And obviously I have to shill for my company and ask you all to check out DBOS and, let me know if you have any feedback on it. But on it, yeah, I'm excited to see what the next 10 years of serverless compute does for us. Whether it's my company, whether it's Lambda, at the end of the day, I just want everybody to be using serverless compute because I honestly think it is the best and easiest way to deploy anything on the internet. I mean, that's why I joined this company, right? Is because I think that is the best and easiest way to deploy on the internet. And I hope it's us that gets us there, but us, I'll still be happy.
Same. As a diehard fanboy of Lambda, I I'm inspired by what Lambda can do, and I'm also inspired to see new takes on how serverless compute should be run. So very excited to check out DBOS and learn more about that as well. Maybe we'll do a future session maybe we'll do a live coding experience with DBOS one of these weeks with BIS as well.
If we did that, I would definitely have to get my Eng team to help because you know, I am definitely want to watch live code. But
Are
my
you going to
Eng
be at
team,
reInvent?
man, I will be at reInvent. Yeah, gonna gonna be great to be. Anyone else who's listening, love to talk chat with you. But yeah, I'll be at reInvent for sure.
And we'll get that session set up with your Eng team, and then you can watch as well. But half the fun is trying to figure it out yourself. But I'll see if I can talk you into doing it
Oh,
yourself.
I've done it. I'm just saying you don't want to watch me do it.
That's what makes it more exciting.
In fact,
But
DBOS is so simple. Our chief of staff, just we asked her to try it out. She hadn't written code in 20 years, right? She was more marketing, go to market sales, and she did it in 10 minutes. She had an app running. She's like, oh, I can still code. And it was great. I mean, she was excited that she could still do it. But yeah, it was that simple for her. So,
awesome. All right. Well, folks, check it out. And Jeremy and I will both be at reInvent. Come say hi and join our Discord for Believe in Serverless. You can find it link on believeinserverless.com. And hope to see as many of you at reInvent as I possibly can. So thank you, everybody, for joining in today.
all right. Thanks.